Wow, hello guys, welcome back to class. I'm super excited to have you guys back to class again. Don't forget, this is Master Vedas Online Academy. So if you are new in this channel, do consider subscribing to this channel and ensure you turn on the post notification bell for more exciting videos. And guys, don't forget that we have policy that we follow here. One of the policies is that you must not skip any part of this video. This is for your own advantage. Alright, it will help you to maximize every principle that we will release while we teach. Then also avoid every unnecessary distractions. Anytime you are set to watch these videos, you must ensure that you avoid every unnecessary distraction. Pay close attention so that you will be able to get the values that we are releasing here. And also, if there be any part in this video you do not understand, maybe when you watch it for the very first time, you do not understand, please guys, you have the opportunity to replay the video over and over again until you understand it. And that's the reason why it's coming in video format. Alright guys, so don't forget to like this video, share this video, and don't forget to make your necessary comments. Now let's get to work. On the board, we are still looking at solutions to first order differential equation. In this case now, we are going to be solving first order differential equation with linear equation, which happens to be the fourth method of solving first order differential equation. With linear method, which is called the use of integrating factor. Of course, like I explained before in the previous lessons we have, when we use method 1, method 2, and method 3, I gave us a condition to know when to use those methods. Now, open your ears wide and open the table of your heart to receive these principles that I'm going to explain one after the other, because this will help you. Don't just jump into the calculation. You may not understand it. Just pay attention to these principles so that when you understand it, you can take a question and solve it while you listen to the examples I solved here. Alright, now let's go. How do I know problems that require the use of linear equation or the integrating factor? How does first order differential equation comes that will require me to make use of this particular method? It's very simple. What you do is that this equation comes in this form: dy over dx plus py is equal to q. So in this case now, there is no x plus y anywhere, whether to any power. There is no x plus y. There is no addition, division, multiplication, or subtraction relationship between x and y. The relationship between x and y here is coefficient. That is for that. Then also the equation must look in such a way that p must be a function of x or a constant. Q will also be a function of x or a constant. So don't forget, where p and q are both functions of x or constant. When I mean constant, the value can just be 3 or 2. There's no x there. Okay, so but it will not be y. So all you do is you must ensure that before you can solve problems using this method, the coefficient of dy over dx must be 1, just as it is here. So if it is not 1, then you have to divide both sides by the coefficient of dy over dx. So this is how the equation should look like. Equation 1. Equation number 3 is the solution to first order differential equation when you are using the linear equation. So this is the linear equation. But before you can find the linear equation, you need the integrating factor. And that's why they said the use of integrating factor. So the linear equation contains a parameter or a section of it that is termed as integrating factor. And this integrating factor has a formula to obtain it. And that formula is what we term as equation 2 here. So to be able to find this if, help me spell like if, alright? For you to be able to get this if, which is integrating factor, this is the formula, which is what? Exponential integral of what? P dx, which is function p. Alright, so that means for me to be able to find the integrating factor, all I need is p, which is the coefficient of y. That's all I need to be able to find the integrating factor. All I need is p, which can either be a constant or a function of x. That is all about that. Now, this is general solution. Once I have been able to get integrating factor where I will impute the value of p, or substitute the value of p rather, then I will now come to the general equation. Of course, I already know my q, which is the function at the right hand side of the given equation. Then impute the value of p of q, substitute the integrating factor that I've already obtained here. Now, when finding the integrating factor, there are some certain things you must put into consideration, because when you have exponential limit of any function, the answer is the function. You need to pay attention to this, because if you miss it here, you are going to have your answer all wrong. Listen to this. Let me come here and explain this. Exponential limit of any function. Okay? Let me put it in the bracket. F of x is equal to f of x. What does this mean? It means that anytime I have exponential limit of anything, this is it. If I have exponential limit x, the answer is just the function. If I have exponential limit x squared, the answer is x squared. If I have exponential limit x plus 5x squared plus 3x cubed, the answer is this function. Similarly, if I have exponentially sine x, the answer is sine x. That is when you have limit. But if I now integrate and I have 2x, there is no limit. This is what will be my answer. If there is no limit, but once there is limit, exponential limit, you must ensure that the answer to that is the function that comes immediately after the limit. Are you there? It's as simple as so. If you understand this concept, then we can start working. Now, on number one, solve x dy over dx plus y is equal to s cubed. Now, you already see that at the right hand side is a function of x which agrees to this. Let's start from the right hand side. Then at the left hand side, we have a y which agrees to this. And we have the y over dx which agrees to this. But something is wrong here. What is wrong here now, guys? Just let me check. The only thing that is wrong here now is that the coefficient of the y over dx is more than 1. So what do? We need to remove that coefficient by dividing both sides by that coefficient, x. So this is solution. Now, we have this as x dy over dx plus y is equal to s cubed. So the first thing we do here is to divide both sides by the coefficient of x, so that we can make the coefficient of dy over dx 1. Now we have dy over dx. If I divide this by x, I have 1. And if I divide this by x, I'm going to have 1 over x y. And if I divide this by x, I'm going to have s cubed over x. Are we there? Simple like this. Now this will have given us dy over dx plus 1 over xy is equal to s squared. This is equation 1. Okay? We have obtained equation 1 where the dy over dx has a coefficient of 1. Then y has a coefficient which is a function of x. And at the right hand side, we have just a function of x. So all we just need to do now is to compare equation 1 here with the standard equation. So compare equation 1 with dy over dx plus py is equal to q. Now, when I compare this equation to this, dy cancels dy, but py is equal to 1 over xy, and y cancels y. That is to say, where p is equal to 1 over x and where q is equal to what? X squared. Q is the function of x that you have at the right hand side. It's as simple as that. So the next thing we do is to find the integrating factor. Once you are able to get the value of p and q, the next thing we do is to find the integrating factor, which is this. Here is the formula, a formula for calculating integrating factor. Are you there? So now, we are going to have this as exponential integral of what is p? P is 1 over x dx. Now, don't forget that we are integrating 1 over x. And anytime you integrate 1 over x, you have limit x. And now, what do we explain in law number 4? Anytime you have exponential limit of any function, the answer is the function. So if I have limit exponential limit x, my integrating factor here is x. Therefore, integrating factor is equal to x. That's all. Substitute for p, integrate with respect to x, Get your answer now. Ascertain. You need to now check this very well. Do I have lien here? If I have lien, then the answer becomes the function. This is a standard, a theory, a boundary condition. When you know boundary conditions, you will not overstep your boundary. Don't forget to subscribe to this YouTube channel if you have not done so. Now, all we need to do is to put down the formula for calculating the general solution, which we call the linear equation. What's that linear equation? We have that y multiplied by integrating factor is equal to integral of q multiplied by integrating factor multiplied by what? Dx. It's as simple as this. So put down y. Now what is our integrating factor? Integrating factor is x. We have obtained it. It's equal to, what is the value of q? S squared. What's integrating factor? X multiplied by dx. So when I multiply everything here, this would have given us xy is equal to integral of s squared multiplied by s would have given us s cubed dx. So in integrating factor, the only section of it that you integrate is the right hand side, because that's where you have integral. You don't need to introduce integral to the left hand side again, because there is no d function here. Alright. Now, when I integrate this guy, I'm going to have x raised to power, increase the power by 1, all over what? 4. Then plus constant. This is the answer to this question, guys. It's as simple as this. That's it. Like I said, once you get P and Q, the question is already half solved. Already half solved. So you don't need to kill yourself. All you need to know is principles. When you know the principles, you become a master, or you automatically gain mastery over that aspect of the course. So I believe by now you have gotten what this course is all about. This aspect of first order differential equation. If I give you another question that you can solve, don't forget to subscribe to this YouTube channel. Don't forget to like this video, share this video, and make your necessary comment. Now let's look at question number 2. Very. Okay, now guys, we have question number 2 on the board. Alright? Now we want to look at this. So this is our solution. And before we can solve this, we need to ascertain what type of differential equation we have. And of course, based on what we have here, we have the y over the x, we have y, and we have a constant at the right hand side. So, constant, a function of x, y to a coefficient that is a function of x, then the y over the x, which looks exactly as this. So all we need to do now is to put down the y over the x plus, I can decide to call this cos x all multiplied by y. This is the coefficient, is equal to what? Cos x. This is equation 1. Now, when I compare this to equation 1 here, I'm going to have that where p is the coefficient of y, which is cos x, and q is what? The value that we have at the right hand side of the equation, which is a function of x2, which is cos x. Like we explained earlier, P and Q are always functions of x or constants. Okay, now, what else do we do? The next thing we do, once you are able to get the value of P and Q, the next thing you do is to obtain the integrating factor. So, we understand that integrating factor IF is equivalent to exponent integral of P dx. Are we there? And this is equivalent to exponential integral of, guys, what is P? P is cos x dx. We just replace P with cos x. Dx remain. Now, let's integrate cos x. Understand that if you are good with integration, you understand that there is no way you can integrate cos directly. Is it possible to integrate cos directly? Alright? So what do? You need to find other trig identity that are related to cos. And understand that cos is equivalent to what? Cos over sine x. Are you there? So if I have, now you recall that cos x is equal to what? Cos x over sine x. So I'm going to come down and obtain my what? Integrating factor. So to obtain the integrating factor, now all I need to do is to have this as exponential integral of cos x over sine x dx. Don't forget everything here, they are all power of the exponent. Now I will make this easy for you. Okay? You can put it somewhere. I will make this easy for you. Now, anytime you have fraction, you see now we have fraction, we are integrating fraction. All you need to do is to check whether if you differentiate the denominator, if it will give you the numerator. Of course, we have sine at the denominator, and if I differentiate sine, I will have cos theta. Is that correct? So if I differentiate sine x, I will have cos x. And I have cos x at the numerator. So now that I know that if I differentiate the denominator, it's going to give me exactly the value I have, or the function I have at the numerator. What do? My answer just becomes the ln of the denominator. Are you there? It's as simple as this. So all I need to do now is that my integrating factor is equal to exponent ln of the denominator. It's as simple as this, oh. Very simple as this. These are boundary conditions that will make you not to overstep your boundary. Boundary conditions that will make you not to overstep your boundaries. Now, don't forget to subscribe. Now listen carefully. And we know that anytime we have exponential ln of any function, the answer becomes the ln, becomes the function. Therefore, our integrating factor for this question would have become sine x. Now guys, we are good to go with this. Then the next thing we are quickly going to do here is to find the general solution, which says that y multiply I dot f integrating factor is equal to integral of q multiplied by integrating factor multiplied by dx. Now I have y multiplied by, what's my integrating factor? Sine x. You see, like I said, this thing is very simple compared to homogeneous. I think homogeneous is more difficult than this, right? Okay, now we have integral of, what is q? Don't forget, q is cos x. Then times multiplied by what? Sine x dx. So when we integrate, we're going to multiply this further. This will giving us y sine x is equal to integral of cos x sine x all dx. Now, the next thing we will do here is to integrate cos x sine x. And now understand that cos x and sine x belongs to the same family, which is what? Trigonometrical family or trigonometrical functions. Are you there? Now, anytime you are integrating the product or the quotient of two identical functions, all you need to do is to use substitution. Here, it was substitution method that we use. Here also, we are going to make use of substitution. So anytime you have the ratio of sine and cos, or the product of sine and cos, this is a conditional boundary condition that will not make you to overstep your boundaries. Alright? Anytime I have sine x over cos x, or cos x over sine x, you must use substitution method. Similarly, anytime I have sine x cos x, or cos x sine x, you will equally use substitution method. Now listen to what I'm going to do here. All you do is to take the second function. It's better that way, okay? Is to take the second function as any other alphabetical letter. I want to work this out, not like this case that will just jump the step. I want to work it out here, right? All we need to do now is to say let u be equal to sine x. Now don't forget that this u is not for this sine x. We are only dealing with the sign that is enclosed with the integral. Are you there? We are dealing with this sign, not this sign. Then also we are replacing this second term and this other term. Just the same way here. This is the first, this is the second. So this is the first, this is the second. Alright? So we take the second term to be u. Now we replace this term and this. Now how do we get the x from here? I'm going to differentiate this with respect to x. I have the u over the x is equal to what? Cos x. Now what else do I do? I will make the x squared of 1 because I'm still going to replace the x. So when I make the x squared of 1, I'm going to have du over cos x. This is what we have. That's it. So at this point now, I will now come to this expression, replace this with u, and replace this with du over cos x. What I need to do, I will come here and have this y sine x is equal to integral of cos x multiplied by this sine x now has been replaced with u, and this guy, dy over ds, is now du over cos x. So this guy will take care of this guy. And now we have this to be what? Y sine x is equal to integral of u du. So when I integrate u with respect to u, understand that the power of this u here is 1. I need to increase the power by 1, which will have given us 2. Then this will have given us y sine x is equal to what? U raised to power 2 all over 2 plus k. And understand that our answer cannot be in terms of y, x, and u. Understand that this is a constant. But we cannot have 3 variables. The question came with 2 variables and is going to end with 2 variables plus the constant. Now we have 4 variables here, or 3 variables plus the constant. So how do we now replace u? We come and look for where we introduce u. Look at it here. From here we said let u be equal to sine x. So I'm going to replace u with sine x. Mathematically this will have given us y sine x is equal to sine x all squared over 2 plus k. So I can finally have this to be what? Y sine x plus sine square x over 2 plus k. You can leave your answer like this. You can decide to say you want to divide both sides. It is a matter of choice. Just a total matter of choice. So you can simplify this further. You can equally leave your answer here. But let's assume we want to take a step further. First of all, we divide both sides by sine x. When we divide both sides by sine x, here will be sine y. And this will have reduced to 1 sine x over 2. And this will have given us k over square x. We will multiply all through by 2. This will give us 2y is equal to sine x plus k, 2k over sine x. Now, like I said, you can always take your constant to be anything. You can take it to be anything. Because this k is a constant function. So I can say let 2k over sine x be equal to a, capital letter A, which is also an arbitrary constant. Then this will give us 2y. 2y is equal to sine x plus a. This is the answer to this question. If you want to keep solving it, but like I explained earlier, you can stop here after you have substituted for u. That's it. So guys, don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos. Don't forget to like this video, share this video, make your friend know about this platform. Now let's head on to solving question number 3. Now guys, we have the very question number 3 on the board, and now we are asked to solve x plus 1 all multiplied by dy by the x plus y is equal to x plus 1 all squared. At the right hand side, let's start from there. We have all functions of x, which agrees to be our cube. Here we have y, which has a coefficient of 1. Here we have the y over the x, which totally agrees to this. But the only disagreement here now is that the coefficient of the y over the x is not 1. So we have to make it to be 1. And what do? We simply divide both sides by x plus 1. And now we have this as, when we divide this first term by x plus 1, we will be left with the y over the x. We don't need to state all the sentences here, right? All the steps. Then when we divide this by x plus 1, we're going to have y over x plus 1. I use brackets. Is equal to, when we divide this by x, we are going to have x plus 1 all squared all over x plus 1. Now, at this point, we will reduce this to dy over dx plus 1 over x plus 1 all multiplied by y is equal to, now understand that the one we have at the denominator has the power of 1. And we can use the what? The laws of indices, or better still have this as x plus 1 all over x plus 1. And this takes care of this. And when we have this done, we will have this as x plus 1. Now the next thing we do is that when we check this equation we just have now with the standard equation, we find that this is the y over the x plus a function of y that has a coefficient of x, and at the right hand side we just have a function of x, which shows that this equation looks exactly like equation 1. So we can call this equation 1. They look alike, the two equation 1s, they are the same. All I just need to do is to say when I compare the coefficient of y here is what? 1 over x plus 1. That I will take as p. P is equal to 1 over x plus 1. And y for the other guy, we have q is equal to what? X plus 1, which is the function you have at the right hand side of the equation. So now we recall that integrating factor is equal to exponent of integral p dx. And now what is p? This is giving us integral of p is what? 1x plus 1 or dx. Now understand that we are integrating a fraction again. Are we there? And now the numerator of the fraction is 1. That shows it is possible for us to have ln. Then secondly, when we look at the denominator, the variable there has a power of 1. That means when we integrate this function, we are going to have the ln of the denominator. We are integrating 1 over what? This. Therefore, we have this as what? Exponential ln of the denominator x plus 1. And now understand that anytime you have exponential ln of any function, the answer becomes the function. So this is our integrating factor. Now that we obtain the integrating factor, all we need to do is to record the general solution, and which is what we call the linear equation. And the linear equation is given as y, 1 dot f is equal to integral of q multiplied by integrating factor multiplied by dx. Are we there? This is the linear equation with the use of integrating factor. So first of all, obtain the integrating factor, then substitute the integrating factor and q, then you integrate. Now, this will give us y multiplied by x plus 1. This is the integrating factor multiplying y is equal to integral of what is q? Q is x plus 1. Integrating factor is also x plus 1 dot dx. Now, understand that in mathematics, if I have a multiplied by a is the same thing as a squared. If I have 3 multiplied by 3 is the same thing as 3 squared. So, if I have x plus 1 multiplied by x plus 1, guys, is it the same thing as x plus 1 squared? Correct. It's the same. So, we have this as y into x plus 1 is equal to integral of x plus 1 all squared dx. The next thing we are quickly going, this is integration of what? Function of function. And when you are integrating function of a function, there are principles that you follow. First, this. First is to differentiate the function of x you have inside the bracket. When you differentiate x plus 1, you have 1. So it does not, whether you multiply a value by 1 or divide it by 1, it does not affect its magnitude. It does not affect its size. It does not affect the value, right? Similarly, then you now differentiate, you now integrate the power. So you differentiate the function inside, then integrate the power. Are you there? Now what do? This will have given us y into x plus 1. Is equal, when I integrate this and listen to what is going to happen here. This will have given us x plus 1. Increase this by 1, which is 2 plus 1. Then all over 2 plus 1 plus k. Now, differentiate this function inside. It will give you 1. So 1 multiplied by this. But assuming this is 2x, then you are going to have 2 here. Assuming this is x squared, you are going to have 2x here. Alright? So it doesn't really, that's why I said earlier, 1 does not really affect what we have here. So, as we push this further, this will have given us y into x plus 1 is equal to, when I add this together, I'm going to have x plus 1 all raised to the power of 3 over 3 times 1 is 3. Then plus k. This is my answer. If I want to solve it further, I can divide both sides by this. It's possible to have that done. So, but this is my answer. I can stop here. Let's take 1 or 2 more steps. But you can stop here. Alright, so this will have given us y is equal to, now when I divide this term here by x plus 1, this cancels each other. Then this will have given us x plus 1 raised to the power 3 over 3 into x plus 1. Then plus k all over x plus 1. Now, understand that has the power of 1. So I'm going to have 3 minus 1. That would have given us 2 at the numerator. So we have y is equal to x plus 1 raised to the power of 2 over 3 plus k over x plus 1. Now, the next thing I'm going to do is to clear off the fraction. And to clear off the fraction, don't forget that this is a constant, so I don't have anything to do with this. This is the only fraction I consider here, which is 3. So I'll multiply the whole equation by 3 so that I will eliminate the fraction on the denominator. And when I have that done, this guy multiplied by 3, we have 3y. And when we multiply this function by 3, 3 cancel 3, we have only the numerator. Then plus, when we multiply this by 3, we have 3k all over x plus 1. All I just need to do is to say let 3k over x plus 1 be equal to what? Another arbitrary constant. So we take this to be a, another arbitrary constant. Of course, you know what we have been doing before now. So in this case, final answer becomes 3y is equal to x plus 1 all squared plus a. This is the simplest level you can solve this question to. Guys, hope this is mind-blowing. Don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos. Like this video, share this video, and make this platform known to your friends, families, well-wishers, and even those that you. See you as we solve question number 4. Okay, now guys, we have question number 4 on the board. Now we are asked to solve dy over dx minus 2y is equal to x cubed cos x. Now let's start our analysis from the right hand side. From the right hand side, we have all functions of x, which happens to be our cube. Then from the left hand side, we have minus 2y. Of course, we have y and we have dy over dx, which partially agrees with this first rule. But now the next thing we are quickly going to do is that when we compare the first term of this particular given equation to this standard equation, we will discover that the coefficient of dy over dx is not 1. So what must we do to this given equation to reduce the coefficient over dx to be 1? All we need to do is to divide both sides by x. Then this would have given us, when we divide this by x, we have dy over dx minus, when we divide this, we have 2y over x. And when we divide this, we have x cubed cos x over x. Now, guys, this would have given us the y over dx minus 2 over x y is equal to, now x cubed divided by x, we have x squared cos x. This we can call equation 1. And this equation now 1 now looks exactly as this. Now that it looks exactly as this, then we can obtain the value of p and q. So when we compare this first term to this first term, it cancels out. When we compare this term to this other term, y cancelled out. Therefore, where p is equal to minus 2 over x. Don't forget, this is minus, this is plus. Okay? Then, and q is equal to x squared cos x. Now that I have obtained the value of p, then I can find the integrating factor. Now we have if integrating factor is equal to exponent integral of p dx. And now guys, what is the value of p? The value of p is minus 2 over x. Then we have this as integral of minus 2 over x all dx. And now this is a constant. I can take the constant out, where we'll have this as exponent minus 2 integral of 1 over x dx. I just want to take out the minus 2 so that I can have 1 over x. Now, you know that when you integrate 1 over x, you will have ln x. Therefore, this will have given us exponent minus 2 ln x. Now, when you compare what we have here to what we had before, you will discover that this is exponential, but before the ln, there is a number there. And there is no way this can cancel out. All I need to do now is to remove the coefficient of the link so that the link will have direct contact with the exponential function. This x is different from this x. This coefficient here, you must remove it before you can apply this theorem number 4. Because the link must have a direct contact with what? The exponential function. So if that is understood, we are going to take this minus to become the power of this, just the same way we used to do in long reading. If I have a log b x, this is equivalent to what? Log b raised to the power of a x. You take this to become the power of the log. That's exactly what we are doing here. And don't forget that this link s is the same thing as the log base e of any function. Alright? So if I have a here, I have a here. This can move to become the power. Why this can also move to become the power? If this is understood, it's okay. Mathematics is application of principles. And when you know the boundary conditions, you will not overstep your boundary. You will not overstep your boundaries if you know the boundary conditions. Okay. Now, if this is understood, we know that we can take this step further by having this to be what? Ln x minus 2. At this point now, this guy cancels this guy. So we are left with what? Only x raised to the power minus 2, which is same thing as what? 1 over x squared, using the fourth law of indices. Take the minus as the reciprocal of the base to the positive power. That's all. Now, this is the integrating factor we just obtained as what? 1 over s squared. The next thing is to what? Put down the linear equation which says that y multiplied by integrating factor is equivalent to what? Integral of q multiplied by the integrating factor or multiplied by what? Dx. This is the linear equation, which is the use of integrating factor. Now we got the value for integrating factor, then we can solve. Now guys, this is y multiplied by what is integrating factor? 1 over x squared is equal to integral. What is q? Q is s squared cos x multiplied by what is integrating factor? 1 over x squared or multiplied by dx. Now don't forget that s squared takes care of s squared. And now we have this as y over s squared is equal to integral of cos x dx. Now guys, when you integrate cos x, you have sine x. That's it. So we have this to be y over x squared is equal to sine x plus. Okay. You can decide to make this linear, since we are dealing with linear equation, by multiplying through by s squared so that we clear off the fraction. Then we have, when we multiply the first term by s squared, which is the denominator, s squared cancel s squared, we are left with y. Then when we multiply this side, we are going to have s squared multiplied by sine x plus. Okay. So you can start solve further. You can solve further. Now, this is our answer. You can decide to say, okay, I want to replace k with another function. Let me expand. It's possible. So, as when we do that, this will have given us x squared sine x plus k s squared. So we simply say let k s squared be equal to a, and now we have y is equal to x sine x plus a in its simple form. This is the answer to this very question, guys. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Even while you are asleep, you will be notified that Master Builders has released a mind-blowing content that will add fresh values to your life. So you see, this is the reason why you need to turn on the post notification bell. While you are asleep, you will receive notification. While you are at work, you will receive notification. And while you are at your reading table, you will also receive a notification that will boost up your reading morale. Guys, don't forget to share this video. Don't forget to like this video, and also don't forget to make your necessary comments. We love you guys. Thank you for watching. See you in the next class. This is question number 4. Now we have question number 5 on the board. So we are asked to solve the y over the x plus 7y is equal to exponential 5x. And now we are asked to integrate this. We are asked to solve this. And we know that since we have the y over the x here, this is first order differential equation. And in solving first order differential equation, all we simply do is to find a way to eliminate the y over the x. And the easiest way to remove the y over the x is by integration. Are you there? And for us to be able to integrate, we must know the category this particular question belongs. Of course, it belongs to what the linear equation aspect. Now, all we need to do is to compare this equation with this, and we see that this is a function of x, and this is a function of x, like I explained, that this can either be a function of x or a constant, and that's exactly what we have here, that this is a constant. Okay, now, we have this as the y over the x plus 7y is equals to e raised to the power 2x. This is equation 1. And when we compare this equation with this, we find out that p is equal to 7 and q is equal to exponential 2x. Hope you have seen this. It's as simple as this. So you see now that in this case, p is equal to a constant, not a function of x. Alright? A constant. So that's why I said p and q are both functions of x or constants, depending on the nature of the question. Now, in this case, now that I've been able to find the value of p, then I can find integrating factors as simple as this. So I have integrating factor is equal to integral of exponent of what? Integral p dx. And this will have given us integral of what? 7 dx. And when you integrate 7, you are going to have your integrating factor as what? E raised to the power 7x. Now don't forget, when you integrate 7 with respect to x, we will have 7x. That's all. Now there is no link here, so there is no way we can cancel out. So this becomes our answer to the integrating factor. This is the integrating factor. There is no way we can cancel out the exponential function because there is no link. Now that we have obtained the integrating factor, we now need to state the linear equation which is dependent on the integrating factor. And now we have this as y multiplied by integrating factor is equal to integral of q multiplied by integrating factor or multiplied by dx. Now I know my integrating factor, also I know q. I just need to substitute. Integrating factor is 7x and this q is e raised to the power 2x multiplied by e. Integrating factor is 7x. Then multiplied by what? Dx. Now when we multiply this, this will have given us y exponential 7x is equal to x. Now listen carefully. Here we can make use of the first law of indices. We have exponential 2x multiplied by exponential 7x. Now they have equal base. I will pick the base, then add up the powers 2x plus 7x, and that will have given us 9x dx. So when you integrate exponential function, what happens? You what? Divide the function by the coefficient of the exponential function. This is the short form of solving it. But to solve this exponential function directly, you make use of substitution method, where you say let u be equal to the function of x, which is 9x. But we don't want to go that way. Then we just apply the shortcut. Then this will have given us y e raised to the power 7x is equal to exponential 9x. When you differentiate 9x, you have 9. Then divide the function by 9 plus k. This is the answer to this question. So, if I want to do more, I want to make it linear. Since I am dealing with linear equations, then I clear all the fraction. Alright? Then, before I clear all the fraction, I need to first of all divide both sides by e raised to the power 7x. So, I'll have y is equal to e raised to the power 9x over 9 e raised to the power 7x plus k over e raised to the power 7x. Okay? So this will have given us y is equal to this guy, we take care of 2. So we are going to have 9x minus 7x. And 9x minus 7x will give us 2x over 9 plus k all over e raised to the power what? 7x. Now at this point, I can decide to multiply all through by what? 9. And if I do that, this will have given us 9y is equal to, if I multiply this by 9, 9 cancel 9, we have only the numerator, which is 2x, plus if I multiply this by 9, I'm going to have 9k, e raised to the power minus 7k. All I just apply now is the fourth law of physics. So when I'm taking exponential 7x to the numerator, I affect it with what? A negative power. That's all. So all I just need to do is to influence the power by a negative sign. That's all. Now at this point, I can replace this guy with what? Another constant. So I can simply say let 9k exponential minus 7x be equal to capital letter A, which is another arbitrary constant. And when we do that here, this will have given us 9y is equal to e raised to the power 2x, which is exponential 2x, plus A. This is the simplest form of this particular question. Guys, you see that solving problems of first order differential equation with the help of linear equation series of integrating factor is very, very simple. All you need to do is to seek to understand the principles that works. So when you know principles, you automatically gain mastery. And when you know boundary conditions, you will never overstep your boundaries. Guys, I hope this lecture added value to your life. So do consider subscribing to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos. Now, to be able to get access to the next session of our class, just check the description below where you will find the link to the next video and more other content that will be of help to you. Guys, we love you. Thank you for watching. See you guys in the next class. Master Vedas Academy.